Hi there. Now we will discuss the use of our Porosity tool. And this is how it looks. Obviously, it will depend from one service provider to the other, but this is a design for the tool of one company, this is a design for another company. But the main idea here is that it changes one electrical signal and convert that electrical signal into a wave that will go all through the formation from the transmitter, will get into the formation and will go back to a receiver. And that wave will contain the information of the formation that we are evaluating. So, multiple uses for acoustic tools. I would like to mention that regarding porosity, it provides an estimate of effective porosity, which is different than the measurements we get from the density tool and neutron tool, because those are an indicators of total porosity. In the case of acoustic tools, we're talking about effective porosity. It is also an indicator of lithology. It can help with determining the stress field orientation, to calculate the rock elastic properties, even for seismic applications, or to complement the information we get from seismic sources. Now, this is how it works. When you're talking about acoustic tools, you mostly will hear these words: monopole, dipole, compressional, shear, and Stoney waves, flexural waves. So the main point here is a type of transmitter. You have a monopole transmitter or a dipole transmitter. In the case of monopole transmitter, they are able to generate compressional waves. In some formation, they are able to create shear waves as well, but not in every single formation. Monopole transmitters are capable of providing shear waves. So this is where dipole transmitter come into place, because dipole transmitter are capable of creating those shear waves in every single formation, in all formations. It gets a little bit tricky because at the end, these ones are not exactly shear wave, or they're referred as flexural wave. But to put it in short, when a monopole cannot create shear wave, it is necessary a dipole transmitter. And this dipole transmitter is going to create non-refracted shear energy, which is also known as a flexural wave. This is how the wave behaves in this case of compressional wave, which are also referred as P waves. The displacement and propagation goes into the same direction. This is the formula to calculate the velocity of the compressional wave. So the transmitter will generate the wave, it will travel through the borehole fluid, will get into contact with the formation. After being critically refracted, will go through the formation and then will go back through the borehole fluid and into the transmitter. This is an example of the shear wave, or S wave, where the propagation and displacement are not in the same direction. An important point here is that shear wave, they do not travel through the fluid, into the borehole, into any fluid, because the shear modulus is 0. Now, these are Stoney wave, they move like that. They are created by the monopole transmitter. And why these Stoney wave are important? Because the frequency is a qualitative indicator of permeability, and the amplitude is used to analyze naturally fractured formations. In the case of a flexural wave, they will move like that because they're created by a dipole transmitter. So it will move in one direction and into the other, like you can see it here in the image. And in this case, a fluctuating wave, the frequency is what is most important here, because at low frequency, fluctuating wave travel at the same velocity as the formation's shear velocity. Now, the factors that affect those measurements, again, the difference between a monopole and a dipole is good to clarify it. We'll be covering as well why using a long space monopole transmitter and why using a cross dipole tool. What are the applications of the acoustic tool data, the one that we just saw on the second slide, and what is anisotropy. Well, the difference between a monopole and a dipole, again, one more time, is that a monopole is used to generate critically refracted P wave and shear wave. Sometimes, with a monopole, it is not possible to generate critically refracted shear wave. And with a dipole, it's possible to generate non-refracted shear wave, also known as fluctuating waves. Why a long space monopole? Well, because when there's a distance between the transmitter and the receiver, so the bigger this distance is better because the wave will have the chance to travel deeper into the formation. If the distance of the transmitter and the receiver is really short or small, the path of that wave from transmitter to receiver might be able just to read borehole fluid or not go that deep into the formation and might just give you reading from the skin. The skin refers to the microfractures created by the drill bit when it's drilling the borehole. Around that area, microfractures are created because of that action. So you don't want to evaluate the properties of the formation in that particular area. You want to evaluate the formation deeper when on the area that is not affected by that phenomenon. So we have that with a long space monopole will create or have a greater time separation of P wave and S wave. And what it's mean by cross dipole? Dipole is like having two transmitter to dipole and put it into orthogonal places, like 90 degrees, to have information in both axes. That is the one that was mentioned. And thanks to that, we can have study the anisotropy of the formation. And what is that? Well, anisotropy is defined as the variation of some physical property with respect to the direction at a single point in the formation. The best example for me to explain that is in this case, in this picture, you have permeability as a property. If you see horizontally, there is good permeability, but vertically, the permeability is not that good. So the same property changes according to the direction. This is how a density lock might look like. And after we measure a compressional wave, here's the different weights of calculated porosity, the Willi time average equation, the same equation corrected, there, and the other two. So we'll get our delta T will be this value, the delta T measured, and the delta T for matrix and fluid into the borehole will be assumed to put it into these equations. The Willi time average is like the most famous one, and this will be the values for assumed matrix. In this case, dolomite will be 43.5, limestone, sandstone, and this is for fluids. Now, this is why it is important to have a velocity for the P wave and the S wave, because with that ratio you can determine lithology. In this case, in this graph, you will use as an input that ratio and the compressional slowness, and you have a better idea of the type of lithology. This is how it is calculated. Remember that shear wave do not travel on liquids because G is 0. One of the mechanical properties is the Poisson ratio. bulk modulus and shear modulus, and this is also helpful information. You can calculate it using all of this. So this is why the acoustic tool is so important, and thank you for watching.